Hello, my name is Eddy Wan, and I'm going to be doing my presentation on the autonomous robotic lawnmower. So in this presentation, I'll be going over my introduction, my engineering goal, my methodology, my results, conclusions, future research, acknowledgements, references, and then I'll open the floor to some questions. So I based my project upon the Ardu mower. So this is a robotic lawnmower which can be purchased from Marotronics, and it comes in a kit which consists of a chassis, sensors, a perimeter wire, and an Arduino board which is used to control the robot. So the goal for my project was to build a lawnmower which would be able to use GPS to guide itself within the lawn. The lawnmowers on the market use physical wires which you lay out around your yard, around the areas that you want the robot to stay within, and the robot would sense those wires and turn around. But my robot would use GPS only to guide itself. So how would I be able to do this? First, I needed to build the chassis. So this chassis would include the motors, the actual chassis itself, and other components such as the motor controllers and the Arduino board, which would be used to control the robot. And then secondly, I would need a mapping program to create the maps which the robot would navigate itself within. So this was created using JavaScript, and it uses a satellite map, and you can click around your lawn and it records the coordinates of your lawn, and it creates a virtual map using these coordinates. And then thirdly would be a navigation program. So in C++, I create a program which tells the robot, basically it uses GPS to locate itself, and then as it's going forward, its GPS coordinate is constantly updating, and when it hits the border of where the coordinates are, it recognizes that its own GPS coordinates matches up with the border, and then it turns around and it keeps going until it hits the border again, and it just keeps going back and forth. And then there also needed to be a user interface. So this was created using Java, and this user interface basically allowed you to control the robot without physically interacting with it. So as for my results, all the components of the chassis, including the motor, the main board, and the sensors were all successfully put together, and it was able to mow successfully. And the power control board, or the PCB, which is what controls the robot, was the only major obstacle in this stage, since all of the individual parts of it needed to be soldered on together, and there was a lot of troubleshooting with the electrical connections, but eventually that was solved. And then as for the mapping program, it was able to, you could just go into satellite program or like Google Maps, and you can click around your lawn, and it would be able to record those coordinates and create a map using that to send to the navigation program. So the navigation program was able to take that map, and it was able to direct the robot and move it within that map. So if you created, say, a simple rectangle as I have here, it would be able to stay within that rectangle. However, the accuracy of GPS has an error of about 1 foot, so within the program there is padding to allow for that 1 foot to be accounted for, so it stays within the map. So this is a video of my results. So as you can see, it moves forwards until it hits the boundary, and it'll turn around 180 degrees and then keep going backwards until it hits the border again. So here it hits the border and then it starts turning. So the ones on the market use physical wires. So when it hits the wire, it senses that, and then it turns at a random angle and moves forward. So the ones on the market use a chaos principle to determine how to mow your lawn. Mine would just use lanes as a human would, which is more efficient. So conclusions, the assembly of the robot was successful and it was able to mow, and the mapping program was able to generate coordinates that could represent boundaries of your yard. And this works for any yard, you just have to create it within the mapping program. And then this navigation system was able to take the map from the mapping program, and using GPS, it would guide the robot to stay within this map. As for future research, uh, I would like to be able to create a app that would more easily create GPS boundaries. So this app would be able to, you could just activate it and you walk around the outside of your lawn and it would record those coordinates automatically and create a map out of it. As well as I would like to be able to create a more efficient algorithm to direct the path. So the commercial ones obviously use just randomly, so that is very inefficient. And mine mows in lanes like a human would, but there are more efficient ways for it to go so that it would take less time and take less power to mow your lawn. I would like to thank my mentor, Robert McGillivray, Noon's Attic, for letting me research there, and Miss Young, the KYRP program, as well as my friends and family. These are my references, and are there any questions?